Chapter 1, Lesson 1, Translations. We're going to start off with some vocabulary here that will take us through the rest of the chapter. So we're talking about transformations, which will be operations that allows us to map an original image to a new image. That new image will be found by sliding things, flipping them, rotating them, shrinking them, or making them grow. They come in two parts. We have our pre-image, which is always the original. It's where we start. It's what's given to you. And then we have the image, which the image is what we have when we are completely done. It's our new picture. One of the things I want to make sure we're careful of as we move forward is some notation. So what's going to happen is for a pre-image, we're going to talk about coordinates on a grid. So when we have those points are named with capital letters. We'll say A, B, C, and so on. Well, when we do a transformation represented by these arrows, we're going to get a new image. That image being a derivative or coming from the pre-image, has a new name. And we denote it with a hash mark that means prime. So point A becomes A prime. Point B becomes B prime. Point C becomes C prime. And that'll happen for each of our transformations as we move forward. We have 4 of them in total, and sometimes you can be asked to recognize or do multiple different transformations. So we're going to have to be careful about tracking these names for the coordinates. We're going to start off with a translation. Now, a translation is when we slide a figure from one position to another without turning it. That means we will not rotate, so no rotating. We will not be flipping it, so no flipping. It can only change its location by sliding in any direction. And then as we keep moving forward, we're going to talk about congruent, which we talked about in our previous chapter. It's when things are the same size, same shape. Let's go ahead and move forward and talk more about these translations. You should make this diagram in your notes. I apologize for that Smart Notebook limited mode watermark. If you don't see it on your screen, it's on my screen and kind of in the way of some of this, so I'm going to try to work around it. So first off, to define it again, we're talking about a translation, which is a slide without flipping or turning. Now, there are 3 characteristics when it comes to a translation. First one, it's going to be the same shape. So if it's a triangle, it's going to stay a triangle. If it's a right triangle, it's going to stay a right triangle. There's no changing of the shape. It's going to have the exact same size. So again, we're not shrinking it, we're not growing it. It's going to be the exact same shape. And the last part is it's going to face the same way as the original. What that's going to look like is I'm going to draw a triangle over here. Now I'm drawing it along with you because we just need to know that it's not going to be perfect in your notes. In an ideal world, these would be perfect. I know I could create one from Smart Notebook, but I'm going to go along with what you guys have too. If I go and this were to be a translation, I would have something that looked like this. Now, I know the sizing is a little bit off, but notice that the triangle is the same triangle. It's still a right triangle with about the same measurements, just moved over to the right and moved up. A non-example of a translation would be if I take this triangle and now flip it over. So I turned it. This could also be looked at as I flipped it over a line. There is a translation that happens with moving it to the side, but it is not just a translation. There's more than one thing happening. This diagram is going to help us when we need to remember what exactly a translation is and how to recognize it. Now, we have a way of doing translations just using coordinates. So translations come in multiple different ways. I could give you a coordinate and give you directions, and you would be able to tell me what the new coordinate is. In the case of the first one we're going to do, point J, you'd be able to tell me J prime. This can be done with or without a graph. And it's going to be expected that you can do both. So I'm going to start with showing you how to do it without a graph, and then we'll come back and do it with a graph. So to start, for this translation, we need to remember a few things. So the points are always x, y, and then we're going to be doing some sort of addition to find our prime point, our new one. I want you to be careful because there are going to be times where it does not look like addition. That is because we will be adding by a negative number. And remember that when we add by a negative number, it looks similar to subtraction. So let's take a look at this first example. We're going to take our ordered pairs and translate them 2 units to the right and 5 units down. So we need to think back to when we were doing graphs and functions, and we talked about directions on the coordinate plane. How when we go to the right, it's positive. When we go up, it's positive. But when we go left, it's negative. And when we go down, it's negative. In order for us to find J prime, I'm going to need to look at what do I do with 2 units to the right. Since it's to the right, it's positive. I like to make a note that it's going to be x plus 2. Since x is our left and right, and since it's to the right, it's positive, I'm going to take my x piece and add 2. The next is 5 units down. And for up and down, it's y. And to go down, it's negative. So I'll be adding by a negative 5. So in order to find J prime, we're going to do negative 3 plus 2, and then 4 plus a negative 5. This will tell me that J prime is now at the location of negative 1, comma, see 5 plus negative 1, negative 5, that's, all right, so 4 plus negative 5 gives me negative 1. My ordered pair is now at -1, -1. Let's look for k prime. So k prime. It starts at 1 for my x, but I'm going to be adding 2 to move it to the right. And then our y starts at 3, but I'm going to add -5 because I need to move down. So k prime is at a new location of 3, comma, -2. We're going to be looking at graphs here in a moment. I'm showing you right now just the mechanics of how we can find the new coordinates before we go ahead and show you what the coordinates look like. Now for I prime, or I'm sorry, that is an L. We have -4. So we're shifting it to the right, so I'm adding 2. Then I have -1. I'm shifting it down, so I'm adding a -5. That means L prime is at -2, comma, -6. So this is how we use addition to help us translate coordinates to find their new image. Let's take a look at what we have next. Now, this will be a quick guide to help us out. You need to copy this down. That for x values, when we move to the right, it's addition. When we move to the left, it's subtraction. And for the y values, we add to go up and subtract to go down. Let's look at how we can do a translation using a graph. I have my pre-image triangle ABC, and I want to move it 4 units to the right and 2 units up. What I would like you to do, and this is just how I show my students, is I'm going to actually count out on the graph where my new points should be. So for A, which is over here at -3, 4, I'm going to shift it 4 to the right. So 1, 2, 3, 4, and then up 2, so 1, 2, to get A prime. And I would like you to note where the new point is. It is at 1, comma 6. And if we think about it, -3, if I were to add 4 to it, gets me to 1. And 4, if I add 2 because I move up, I get 6. So it gives us an example of how this looks with addition as well as how it looks on the graph. Let's work on point B. So point B is at 2, comma 4. But I'm going to take it and go 1, 2, 3, 4, 1, 2, and I get B prime. In its new location, it's at 6, comma 6. Again, I did +4 for my x to go to the right, and then +2 on my y to go up. Now I'm going to take and move my C. 1, 2, 3, 4, 1, 2. Now I get C prime. Now, we would want to connect the dots to make our shape. Our shape should be the exact same size, facing the exact same direction, but all we did was slide it across the graph. I'm going to actually pick up my triangle and see, is it in the spot it's supposed to be? So I went to the right 4, up 2, and my triangle fits exactly where it should be for these coordinates. This is how we approach doing translations, with both a graph and using our algebra skills. You will be expected to be able to do both pieces. If I gave you a pre-image, whether it's a set of coordinates or a graph, you can perform the translation on both the graph and provide me the ordered pairs for the new points. I should add that C was at -3, 0, and now C prime is at 1, 2. I hope this video is helpful. If you have any questions, please feel free to ask.